discuss the synthesis of alpha comma beta unsaturated ketones, aldehydes, which is the final product of an aldol. So basically beta hydroxyketones or beta hydroxyaldehydes, the product of aldol, they can easily undergo dehydration under heating conditions for open chain beta hydroxyaldols, okay, to give us the alpha beta unsaturated product. So over here, this is our beta hydroxy ketone, where there is a leaving group on the beta carbon. Okay, now this is your alpha carbon and beta carbon. After dehydration, they are having the unsaturation. So it is called a alpha comma beta unsaturated ketone. Okay. Next. So whenever there is the OH group in a position that is beta to the carbonyl, so it will be easier for it to lose the water molecule, that is dehydration will occur at a faster rate than the dehydration of any other ordinary alcohol, okay, because there is a carbonyl group present over here, okay. So for example, if we are taking a molecule such as benzaldehyde, okay, and we have taken acetone, now out here benzaldehyde is a different molecule, and we know this is a ketone over here, that is acetone. Aldehydes are more reactive than ketones, so over here the enolate of the ketone, which is having the alpha carbons, alpha H protons, will be making a nucleophilic attack at the benzaldehyde, okay, and once that happens, that means under the influence of a basic medium, we can think that this is our benzaldehyde, our carbanion. So this is the electrophilic center. This is making a nucleophilic attack. Always consider benzaldehyde to be excess. So if that is the case, then out here we will have a situation in which both the alpha carbons of the acetone will act as a nucleophile towards two separate benzaldehyde molecules, and we will get an intermediate having this particular structure. Now, if we heat this molecule, two molecules of water will be eliminated from the above molecule, and that will lead to the formation of a double aldol product, which can be represented as follows. Okay, so the final aldol product over here is the alpha comma beta unsaturated ketone. Okay, so aldol reactions, one can say, also gives the most stable product, since the reactions are reversible and undergoes equilibration and is also controlled by thermodynamics. So in case, say, we are considering a intramolecular aldol condensation as shown below, so we have been given this type of a molecule. Now, on reaction over here, the major product that is formed is actually this. But not this one, or say that one. So this is the major product and is the most stable one found. Why is this? Why we are saying that A and B are not our favorable products, but this molecule is. Now, over here, what is interesting to understand, that this unit over here is a aldehyde and that portion is a ketone. What do we know so far? Aldehydes more reactive than ketones because of electronic and steric factors. So we will say this carbon is better electrophile. Okay, this carbon is better electrophile. Now, if at all attack, or we say carbanion is formed over here, so if this is our nucleophilic carbon, then the molecule A will be formed via reaction of this particular alpha carbon with that particular carbonyl. Okay. Now, if we react this particular carbon, that is this one, where a negative charge is created and that reacts with this carbon, then the product B is formed. Okay. But which is one is the major? This one. Okay. So over here, if this particular carbon is deprotonated and then the nucleophilic attack happens on the aldehyde, then this major product is formed. Okay. Now, as we have discussed that the aldehyde is more reactive, okay. So over here, the reaction can happen either from this carbon or that carbon after loss of proton. But the 7-membered ring is less stable. 7-membered ring is less stable due to angle strain. We know that. Hence, it becomes less favorable. So, under those conditions, attack from this carbon to the aldehydic carbon takes place. Okay, and so this molecule becomes our major product. Okay. Now, some points on the elimination of water, that is the dehydration. So we will discuss over here the mechanism of the dehydration of the aldol product. So let us say over here that it basically is a two-step base catalyzed dehydration. That is the first point, which is also called, so this is a two-step base catalyzed dehydration mechanism called beta elimination or the E1CB, which is the stepwise elimination involving conjugate base, which begins with the deprotonation of the alpha carbon to form a enolate. Then this enolate ejects the beta leaving group, obviously our hydroxide. So Out here, what we are saying is if this is your aldol, for deprotonation, the hydroxide will take up the hydrogen from the alpha carbon, which exists as the enolate, and eventually that comes back, that goes in there, that runs away. Our alpha beta unsaturated product is formed. Now here, what should be the retrosynthesis of alpha comma beta unsaturated ketones oblique aldehydes, or that of aldol? So one can say that the dehydration step is no more than a functional group interconversion. So during the retrosynthesis of a alpha beta unsaturated ketone or aldehyde, one can make the same type of disconnection that we did in the beta hydroxy ketone or aldehyde. So whenever you are given the alpha beta unsaturated ketone or aldehyde, try to think of an FGI which involves the addition of water molecule to produce the beta hydroxyaldehyde or ketone, and then you can just repeat the retrosynthetic pathway that we had used for any aldol, that is the beta hydroxyaldehyde or ketone. And as we know, on disconnection, these type of synthons will be formed, for which our synthetic equivalent will be as follows. So that is all we need to do. Okay, so that will be the end for synthesis and retrosynthesis of beta hydroxy aldehydes or ketones or alpha beta unsaturated aldehydes or ketones. In the next part of the lecture, we will be taking up mixed aldol condensation reactions and the regio control that involves there with the enolates. Okay, so that will be the next part. Keep visiting Sarasa classes. Thanks for listening and have a great day.